Hi everybody, welcome to UMBC in the Loop. I am Dr. Ellen Handler Spitz and I'm the Honors College professor here. And I'm talking today with Professor Govind Rao, who is Professor of Engineering and also Director of the Center for Advanced Sensor Technology. And we were joking before, we want you to know that sensor is an engineering term and doesn't have to do with red penciling things and saying you can't publish. So I am a professor who teaches humanities classes. I teach about art and literature and aesthetics. And when Professor Rao invited me to talk with him today, I protested that I don't know anything about engineering. And he then said, oh, but that's exactly right. That will give me a chance to explain what engineering is all about. And one thing that really intrigued me about talking to Professor Rao is the whole idea of what an engineer is. Because the word engineer sounds a lot like engine, and it comes from a Latin word ingenium, which has to do with the spirit of a place. And it has to do with the same root as genius, intelligence. You can even think of the word genie, who makes marvelous things appear and happens. And I love that idea. And the French word for engineer is ingénieur, which goes back to the Latin. So I wanted to ask you to talk a little bit about what does it mean to be an engineer?
You know, it's interesting that you say that, and thank you for agreeing to do this. Part of what I think makes an engineer a better engineer is to have a very open approach to any problem that we're trying to solve. And most engineers, if you ask them what it is that you see yourself as, would describe themselves as a problem solver first and foremost. But just about every problem has a solution that's not particularly straightforward, and creativity is pretty much the hallmark of any good engineer. And so it was very interesting to me to learn about the root words, because those are some of the attributes that we try and inculcate not only in our students but in all the projects that we deal with. And some of them end up requiring really out-of-the-box thinking. You know, to that, it's really interesting, our earlier conversation about how you were describing art as building and making new forms, new things. I think that's very much the soul of engineering also. And so I think we're not as far apart as you might think. You know, initially people do have this reaction to engineering and science, the whole STEM debate, where it looks incredibly complex, but I think ultimately we're all human beings, and that's the common thread of humanity that connects us. And I think that's what attracts us as engineers, and my lab in particular. We're all about trying to make new devices, inventions that'll help people lead better lives.
You know, apropos of etymology, the ancient Greek word for art is techne, which is the root word for technology. And you are, you know, the director of this advanced sensor technology lab. So even in the root word of techne, you have this sense that there's something artful that we share, and I think that's really that's really important. And also, I love what you said about solving problems, because sometimes formulating the problem is really important. Formulating the problem, if you formulate the problem differently, then you can solve it. If you keep formulating it the same way, is that true? That if you keep formulating it the same way, you can't solve it, but you have to. And I think that's very artful too, to try to imagine another problem. Mm-hmm. And then the solution can emerge.
Yeah, and you know, again, it's a question of how you learn to do something. Very often you learn the baby steps first, and then things get more complex. But as you get to problems that are really difficult ones, they involve so many intricate juxtapositions and connections that it's no longer possible to take a simple linear approach. And that's where you distinguish really creative, good engineers, because you quickly learn that you need to approach a problem from many different angles, much as an artist does. It's not one-dimensional. It's something you really explore.
So, do you think that that you need to learn? You have to learn a certain body of material then before you can be creative. I mean, we were talking about this with my students in a class I'm teaching, sort of debating about first things. What comes first? Does the idea come first? Does the inspiration come first? Does the image come first? Does the dream come first? Or is it in the process of working with materials or learning that the ideas come? Or is it sort of undecidable in engineering? I think in the arts, I think it's really undecidable. And also I think it depends on styles, personal styles of working. But in a science lab like your lab, I'd love you to just talk about what you do in your lab maybe, and maybe some of this will emerge. What is an advanced sensor technology lab for those of us who really...
Our it's interesting. So we look at big problems, and I'll give you one big problem. I'll give you several examples. But one big problem that's facing the world is infant mortality. While we're doing this interview, we're talking for about an hour. 450 newborns will die. That is the death rate amongst new lives entering this world. And the real tragedy is not just that they're dying, that's bad enough, but many of them are preventable. And they're preventable because all you need to help a baby survive is to give them a nice, comfortable environment, much like the mother's womb that they've emerged from, and keep them in stasis such that they can grow and thrive and prosper. In many places, women go into labor, give birth outside of a hospital, and one of the hardest things that a baby has to do is just keep its body at the right temperature. Even advanced nations aren't immune, as we saw in the Hurricane Sandy. When the power went out, they had to transfer these precious little newborns to another hospital that had functional incubators. So that's one project where we're putting a lot of effort to come up with low-cost sensors that'll allow physicians, caregivers to not only provide the baby a comfortable environment, but also monitor their vital signs. How can you measure whether the baby is breathing okay, whether the baby is getting enough oxygen, whether the baby has enough nutrition? Now, these are currently devices that you would find readily in a first world setting or even in the third world in an advanced hospital setting. But where the bulk of people are born in impoverished or low resource settings, it's hard to come by these tools. And so we're trying to come up with sort of paradigm shifting technologies that will allow you to make these measurements in a very low cost manner such that it's affordable and its benefits spread throughout.
Professor Rao, tell us what actually a sensor is. It's S-E-N-S-O-R.
And the root word is sense.
Yes.
And so you actually measure and identify a particular component or substance. So one sensor that might be very familiar to you is glucose, which is a molecule that's sugar, that's present in all the nutrition that we partake of, and that's what ultimately gives our cells the energy. That's what allows an artist to become creative. You do need that sugar to fuel your brain cells. And that leads to another big problem. So there is this disease called diabetes that I'm sure you're familiar with.
Yes.
And that has to do with the body being unable to produce enough insulin, which is a hormone that regulates your sugar level. And all our bodies have evolved. We're very capable of maintaining the right temperature ourselves. The right level of nutrition is also equally important, and that is tied into glucose regulation. Our bodies need sugar for all the cells to survive as an energy source. And that sugar has to be maintained and controlled in a tight range. If you have too much sugar in your blood, that's a problem. It can have all kinds of complications leading to kidney disease, blindness, and eventual death. Or if you have too little sugar, you just pass out. So it's really vital to exquisitely regulate that sugar. Now, it turns out in some people, for a variety of reasons, they lose that ability to control their sugar. So most diabetics have to inject themselves periodically with insulin.
Yeah.
And to do that, you first need to figure out or sense how much glucose there is. And what you do now is you take a little needle, get a drop of blood, and put it in a little meter that tells you how much sugar.
I've seen friends do that, yes.
And that turns out to be one of the most important things for a diabetic to do, to actually monitor their blood sugar on a pretty regular basis. The guidelines call for 4 to 7 measurements a day, perhaps more.
Goodness.
Yes.
But that's very intrusive in somebody's life.
Very much so. It's painful, it's inconvenient, and as a result, most patients don't do it, which means their blood sugar fluctuates wildly.
Yes, yes.
So one of our projects is looking at how can we make this much simpler, make it non-invasive.
Yeah, that's great. That's great. So it could be done less frequently, or it could be done
painlessly,
monitored without the patient's own intervention, or?
Yes. The idea is an automated device that'll tell a patient what their blood sugar is.
That's brilliant. That's simply brilliant. That's wonderful.
So, but to do that, you not only have to formulate the problem, the problem that the current technology is painful, inconvenient, and come up with an out-of-the-box solution. And our out-of-the-box solution has to do with just observing that ultimately our skin is not perfect. It leaks constantly. You're always giving off moisture. And so this led to the idea that can we see whether there's enough glucose diffusing out of the skin? And so what we've come up with is a neat device that'll collect the glucose that's diffusing through the skin and measure that. So that way the patient will wear a device that's unobtrusive and simply be in contact with the skin. It could be design, we could use some art, come up with a piece of jewelry.
As you are from India, I wanted to wear something from India.
Thank you.
Oh, that's so interesting.
But this, again, has to do with the whole process that you talked about. It's not something that an engineer can do by themselves. I really rely on a team that we have at our center, CAST, the Center for Advanced Sensor Technology, that's the abbreviation, that really pulls people from many different disciplines. And that is the heart of our ability to come up with solutions. We have a diverse ecosystem of people, and any ecologist will tell you the most robust ecosystems are the ones that have multiple species interacting in them. And so we thrive on that diversity, not only in terms of fields, but backgrounds. People are truly, we're an international mix. We're a real motley crew.
It's fascinating to me because there's so much empathy in this project. I mean, there's empathy for the patient who is suffering with the diabetes and who has to keep on injecting himself or herself all the time. So the project is psychologically important. It's a psychologically because it depends on having somebody who can say, look, I know your projects seem to be connected to medicine, and I think that it's very, very interesting to think about the way in which the most brilliant physician, who is incredible at diagnosing an illness, can fail if the patient doesn't comply. If the patient can't comply, the physician says, okay, you have to inject yourself 7 or 8 times a day, but the patient is maybe an artist who's painting a great picture and forgets, when you're working, or a writer, you forget. You're in the zone, we say, you know, and you're busy. You can't keep doing that. It takes you, if you did it, it would take you out of your, so here you come along, the engineer, and you come up with something which is extremely valuable, not only from a medical point of view, but also from the point of view of the empathy of the patient.
And ultimately, that's what we're about. It's empowerment. Create the tools using our technology to help people lead better lives, and do it for a broad section of humanity, not just the first word, but the other 99% also. We are incredibly privileged in this country with access to just about everything you can imagine, and yet our work isn't done until everyone can have lives of dignity and access to really basic health care. And that's what we're trying to use some of our talents towards. Can we come up with solutions that really benefit a broad cross-section of mankind? And what's interesting is all this then ties into our education. So I teach a sensors class, and some of these projects, so for example, building a low-cost incubator, was a project that I assigned to teams. So they had to research different countries or regions of the world where they might market this product and what local features they would have to consider. So it was very interesting just to see the student reactions, because I had one team develop an incubator for Ethiopia. And so after the class, I was asking one of the kids, who typical UMBC profile, first generation, going to college and working at the same time, putting himself through. And he said it was eye-opening for him to realize that there are people in this world who live on an income of $1 a day or less. And so that just opens a whole new dimension. You know, so you hear a lot of this globalization and competing across the globe, but people don't really understand how other people live, and I think that's vital.
And that raises the whole question of the way in which science connects the connections between the disciplines among us, because I'm listening to you and I'm thinking of anthropology, thinking of how the anthropologist goes and studies how people are actually living in different cultures. And not only the poverty perhaps, but also the cultural differences. I mean, when you mention incubator, I'm thinking an incubator is used for a premature baby. So I wonder how it would feel to be a mother in a country where there isn't a lot of medical knowledge as here, and to give birth to a tiny, undersized infant, and then be asked to put the baby into an incubator. Even the mother has to give up the child in a sense for this, but the mother it has to be explained to the mother that if she can't do it, she will lose the child. Mm-hmm. And those things it's very interesting to me to think about the way those cultural themes have to be taken into consideration by the doctor and by the scientist, by the medical researcher.
You know, and it's so interesting you say that, because as an engineer, I have a natural affinity for technology, and you make the assumption, build it and they will come, build a better mousetrap. And that's not always true. You know, human beings are peculiar. You know, they're not like us engineers. They do strange things and behave in unpredictable ways. And so that's part of the challenge, to expose my students to the fact that ultimately there is a human being that's got to be connected to this technology. So to your point, we actually talked to some social workers and outreach professionals and said, you know, what's it going to take for alleviating this anxiety? And they said, you know what, you have to understand the local culture. Forget the mother. Go talk to the mother-in-law. That's the one who has the greatest influence.
That's wonderful. Yes.
And I would never have thought of that.
No, of course. That's fascinating. That's absolutely fascinating.
These are some of the things we're learning on the job, and my students are learning too. And so this is something that is taking their education.
The reason this conversation makes me so happy, I will tell everybody who's listening to this that the way Professor Rao and I actually met was through a mutual student who is studying literature with me and studying engineering with Professor Rao. And I wanted to ask Professor Rao permission to allow the student to hear a lecture by a brilliant British intellectual, Marina Warner of London, who had come to the United States to talk about a new book, her latest book on the Arabian Nights, called Stranger Magic. And this young student of ours is a wonderful reader. She reads literature with such psychological sensitivity. And when I was teaching at Stanford, I often had pre-med students, science students, engineering students who would ask me for letters of recommendation. And I would say, why me? I can't recommend you for your science. But I would write letters in which I would say, and I'm so glad this conversation is supporting this, that understanding in a deep way something about human psychology and empathy and the way cultures work, this whole thing of talking to the mother-in-law, because she has the power in that particular constellation. These issues are to be found very often in the arts, in ancient studies, in paintings, in sculptures, in drama and poetry and epic poetry. Oh, and by the way, this is very daring of me. Do you know that I actually, after going to India 4 times, I actually use an abbreviated version of the Ramayana in my teaching? And if you would ever like to come in and talk to my students about it.
I might take your course myself.
Oh, no. I should take yours. So if going back to the baby who fascinates me, the baby who is born into a world, an outside world from the womb of the mother, which is different in every possible way from the mother's womb. How does it work? I mean, what kind of device could there be that would help to regulate, that would help the baby to maintain the proper body temperature and so on? How would you think about? I mean, how would one think about that?
So again, this is an example where, when growing up in India, not many homes had refrigerators. That was a luxury, and in northern India, summers can be quite brutal, in excess of 120 degrees, and so people have adapted over millennia and come up with very innovative solutions. And one of the simplest ways to get a cool drink of water is to have a clay pot that you store the water in, and the water evaporates and the water cools down by about 10-15 degrees. And so our thought was to combine this clay pot with a little chamber, and thereby in the hot summers cool the contents of that chamber so that the baby can have its own portable air-conditioned environment. And in the winter, we thought of a very simple system that would be solar powered and have a readily available truck light, headlight bulb or something as a heating source to warm the baby. So very simple, appropriate technology tools that can make a dramatic difference. Because these are not areas of the world where a plug-in incubator will work because there isn't any electricity. So it's interesting, we describe this concept now to an NGO that has field stations in Nepal and in the Copper Canyon in Mexico, where this is a huge problem because many of these isolated communities live hours from any hospital or medical facility. And there's one more corollary to this, and the Gates Foundation has done admirable work in this, because ultimately there's a vicious cycle between overpopulation and poverty. And the reason populations explode is that when you have high infant mortality, parents can't afford to lose a child, so they end up having more children as a form of insurance.
Yes.
So if you can assure that the child will survive, people have shown dramatic results
That's
on population growth.
Uh-huh.
And ultimately, this is a rapidly warming planet that we all share, and we've got to do something
And
about
the
it.
parents become invested in the child who's alive and raising the child and caring for the child, and yes, it makes perfect sense.
So, we see these multiplier effects of our work.
The other thing that I love that idea, because the idea of the clay pot is something that's familiar to the mother. She grows up with this, and using materials that are familiar, rather than when I walked into this studio for this program and I saw all this technology around me. So you want something that's familiar, and I think earlier we touched on it, but you used the word anxiety, and I think that that's very important. I think that there's a lot of fear. People are afraid of something new. Almost always. And they're used to, even when it doesn't work very well, they're used to it. They want to stay with it. And when something, that's why you said, well, the engineer, the scientist says, look, this is much better, let's go for it. But there's a pullback. There's a pullback away from that. So I think that the scientist, even we see this all around us, in our country, people who are very afraid of science.
It's interesting. I think there may be something to this. A colleague of mine observed that the way we interact with our children, when we're reading to them, for example, you put them on your lap and you hold a book, so there's this sense of intimacy and love that's being shared. Whereas if it's math, it's usually someone yelling at a child saying, do that drill. So I wonder if the roots are, inherently planted at a very early age.
Wonderful. I think that's a marvelous insight. So, that is absolutely, because I write about this. This is my area. I write the children's book reviews, for the New Republic magazine, and I've written several books about this, and it is, and I call this there's a British psychoanalyst who used this term, the holding environment, Donald Winnicott, and there is this sense of a literally holding environment with the child sitting next to you or several children and reading to them. I even read to my students the other day in the Honors College. There is something wonderful about that, but you're right. When they're teaching with the math teaching or the science teaching, I think it could be wonderful to bring some of that warmth into that kind of teaching. It would make it, and the other thing, let me ask you about this. Science is supposed to be very objective. Math problem has got to be done the one way, and it's got to be done the right way. There's no, and yet when I talk about reading stories to children, there is a text, but the parent is very free. If the bear says grrr, grrr, you can make it very, or you can say grrr, you can change it. And what do you think about the personal, individual learning styles or the subjective elements in the learning of science, especially when one is growing?
And I think technology is helping in that regard, because I think there's an understanding now that experiential learning is much better, community-based learning is much better. So putting together clusters of students, I think our chemistry department is doing some groundbreaking work along those lines. It's team-based, project-based, as opposed to textbook, pedagogy, drills. And I think about when you were a child, how you explored the world. It was tactile, it was touch, taste, all the senses brought to bear. So we need to connect with that, figure out how we can adopt that with all these wonderful simulation tools we have to create this rich learning environment. I think that's going to be the trend of the future. But I think the key there is, I think the most creative people are going to be those who can do both left brain and right brain activities and flip back and forth.
Also, Professor Rao, I think one is the most precious resources of youth is curiosity. And I was actually in New York. I was on the subway, and a little girl was there, and she sort of struck up a conversation, and she started to say, a strange little girl, and she started saying, she said, "What's that?" She pointed to a symbol over the door. "What does that mean? And what is that? And what is that?" And she was asking me, and I, her mom was there, and another child, and I started to say, this sign means you mustn't go out that door. But what was striking to me was that her little mind, was full of questions. Why, how, wherefore? And this is the most precious, and I think that some of this rote stuff, you got to do it this way, stamps out. It's like taking your foot and crushing out this little delicate little plant of curiosity, which we really want to grow and foster in our students.
Mm-hmm. Yes, and I think having said that, there is a balance though. Some subjects like engineering do need that hard foundation.
Yes.
Mathematical tables, you have to learn by rote. There is no, eating your spinach. It has to be done. And so some things, but beyond that, you're absolutely right. I think allowing people's curiosity to flower and letting it lead them down different paths. In fact, that's what we do. So for me, the ideal grad student is a curious student, one who's always asking. And CAST is all about, there's a cast of characters who work with me. We're always looking at things and saying, how can I make this differently? How can I make it better? Even simple stuff, you just are always thinking about it. To your point about patient anxiety, you go to hospitals now, they look more like art galleries. People have been very tasteful in decorating them, painting
even
the
walls.
Even
the nurses now wear flowery outfits. They don't wear those white clothes anymore with little hats. When I was a child, the nurses wore these very stiff white. Now they...
But here's the odd thing. That's all for our benefit. If you look at the world from a patient's point of view, who's flat on the back, they're still looking at ceiling tiles and fluorescent lights. So one of the things I'd like to do if I were ever a hospital director is have artwork that's mounted on the wall, on the ceiling.
Like Michelangelo's Sistine ceiling.
Exactly, the Sistine Chapel, perfect example. So simple things like that, I think, to always question and look at things just a little differently.
You're making me think of a children's book. Did you ever see Bemelman's Madeline? In an old house in Paris that was covered with vines, lived 12 little girls in 2 straight lines. In 2 straight lines, they broke their bread and brushed their teeth and went to bed. And anyway, one of them gets sick. What is it? Oh, it's appendicitis. And she is in the hospital. And she's lying on the bed, just what you said, and she looks up and she says the following: "The crack on the ceiling had a habit of sometimes looking like a rabbit." So, of course, exactly, she had to look, but she used her childish imagination, and the crack wasn't just a crack. For her, it was a rabbit. But I really want to, could we pursue this for a minute? This whole question, because it really is fascinating to me, the question of learning by rote, memorizing. You have to memorize, I guess, the periodic tables, or I don't know what it is in science. You have to know these things in order to be creative. And I believe so strongly that we have lost this in the arts. I mean, why is it that children and students are not asked to memorize poetry? Last week, 2 weeks ago, I told my students they were reading Virgil's Aeneid. Not one of them in that class has ever studied Latin. And I told them and they had a professor from Johns Hopkins who came to give a lecture for them, and I told them this is the most beautiful Latin that you will read. And I gave them lots of choices of great passages from the Aeneid with interlineal translation, and I said, you must memorize one famous line, put it into your mind, forever you will have this. So I don't think we're so far apart in terms of needing that kind of learning. It's because that becomes like the furniture of your, the mental tools of your mind, and then out of that, forsan et haec olim meminisse juabit, perhaps one day it will be pleasing to remember these things. You can use it. Always use it if it's inside your head. So I'm not sure that we should give up on that, but we don't want it to crush.
No, I agree. And again, I think for all these young students who are the interns, I think giving them the exposure to both sides, just like we have the general foundation requirements. My engineering students take your course.
Yeah.
I think the other way should also be done, where
Yes.
humanities students take some technology courses, because like it or not, that's what's defining our lives.
And also we don't want them to be afraid.
Yes.
Well, thank you so much. It was an absolute pleasure to talk with you. And we appreciate your listening to our program.
Thank you, Professor Spitz.